All right, this is Algebra 1B Part 2, Unit 3, Rational Expressions and Functions, Lesson 2, Multiplying and Dividing Rational Expressions. I'm going to approach this from the point of view of fraction arithmetic. A rational expression is nothing more than a fraction. And so this is connected to fraction multiplication and addition, or multiplication and division. So let's work with fractions first. Fractions, and we're going to multiply. So let's do 2/3 times, let's do 9/8 times 9/8. Okay, 2/3 times 9/8. Now you've been told before that you can simply multiply straight across, and that is absolutely true. 2 times 9, 3 times 8, multiply straight across, you get 18 over 24, and you can reduce. Notice they both divide by 6, so I'm going to divide by 6 on top and bottom and get 3 over 4. Okay, and that's one way to do it. Another way, and this is the way I'm going to focus on because it's the way we're going to approach the rational expressions, is we can factor the numbers on top and bottom. So 2 and 3 don't factor, but 9 factors. 9 is 3 times 3. And 8 is 2 times 4, which is 2 times 2. Okay? And what I'm going to do, this is called factoring and reducing by cross-canceling. So 2 over 2 is 1, it cancels. 3 over 3 cancels. And all that's left is 3 over 2 times 2. 3 over 2 times 2, or 3/4. Same answer. But we arrive there a slightly different way. We factor the numerator and denominator, and we reduce. Okay. All right, so that is the essence of what we're going to be doing with our rational expressions. Now, I do want to show you a division problem. So division, let's say we had the same problem, 2/3 divided by 8/9. Okay, there's a little saying, yours is not to reason why, but to invert and multiply. We learned early on in middle school that to divide is the same as to multiply by the reciprocal. So 2/3 divided by 8/9, we keep the first, 2/3, we flip the second, 9/8, and it becomes a multiplication problem, whereupon it's treated the same way as before, 2/3 times 3 times 3 over 2 times 2 times 2, with the 2's cancel, the 3's cancel, leaving 3 over 2 times 2, or 3/4 again. Okay, I set it up that way on purpose. All right, so multiplying straight across, dividing, keep the first, flip the second, multiply straight across, but this idea of factoring and canceling to reduce, rather than reducing at the end, is where it's at. Let me show you what I mean. Okay, let's take this expression here. Let's take 45q squared minus 3q minus 6 all over q squared times 14q squared plus 10q all over 35q squared plus 11q minus 10. Okay? And remember what we did. We factored first, and then we saw what could cancel from top and bottom, what common factors existed on top and bottom. So we're going to factor. So the first step of factoring a quadratic is to determine if there's anything that divides evenly into all of them. 4, 3, and 6. Think about it. What number divides evenly into 4, 3, and 6? And the answer is 3. They're all divisible by 3. So I'm going to write a 3 out in front. Okay, and I'm going to divide. 45 divided by 3 is 15. Use a calculator if you need to. 3 divided by 3 is 1. 6 divided by 3 is 2. Okay, over q squared times Okay, factor out of here a 14 and a 10. 2. 2 can come out of both. And they both have a q, so I'm going to take the smallest exponent, which is 1. So that's 1q. Okay. 14 divided by 2 is 7. Q to the 2 minus 1 is q to the 1. 10 divided by 2 is 5. Q to the 1 minus 1 is 0, so the q is gone. Over. Okay, and look for anything that divides evenly into these, 35, 11, and 10. Well, 11's prime, and 11 doesn't go into 35 or 10, so there is nothing there. Okay, so I'm going to keep that the same here for now. 35q squared plus 11q, q minus 10. Okay, and now we've got some trinomials to factor. You recall the guess and check technique here. So factors of 15 are 1 and 15, and 3 and 5. Factors of 2 are 1 and 2. So I'm going to write 2 sets of parentheses. Don't forget to bring down my 3 from before. Factors of 15, I'm going to try 3q and 5q. Factors of 2, I'm going to try 1 and 2. And when we multiply the middles and the outsides, they should subtract to make 1. They should subtract to make 1. So 1 times 5, 3 times 2, 6. Yep, they're going to subtract to make 1. If the 6 is positive and the 5 is negative, that will work. Okay, so the 5 needs to be negative, so that needs to be negative, and that needs to be positive. All right, so that's a little bit of a review of how to factor a trinomial. This is about as hard as it gets here. Okay, over q squared. I'm going to write this as q times q times 2q times 7q plus 5. 7q plus 5 doesn't factor anymore, but let's factor this trinomial here. Factors of 35 are 1 and 35. And 5 and 7. Factors of 10 are 1 and 10 and 2 and 5. A little bit of guess and check here. So I'm going to guess 5q and 7q. And factors of 10, 2 and 5. Now we want the middles and the outsides to subtract to make 11. So the middles, 2 times 7. Outsides, 5 times 5, 25. 25 minus 14 is 11 if the 25 is positive and the 14 is negative. So we want the negative on the 2 and the positive on the 5. Boom, boom, boom. All right, here we go. Okay, there we go. We've got it factored. All right, so now we're going to look for common factors. 3, no, 3 only on top. 3q minus 1. Nope, no 3q minus 1. 5q plus 2. Oh, wait a minute. Did I make a mistake? I bet I made a mistake. Let me check this again here. So middles, that makes negative 6. Outsides, that makes, oops, that makes negative 5. Sorry, negative 5. Outsides, that makes positive 6. That makes a difference of positive 1. I need to make a difference of negative 1. I do have the signs backwards. Okay. So here we go. This needs to be negative. That needs to be positive. There we go. All right. So 5q minus 2 does exist on top and bottom. Okay. And q exists on top and bottom. 7q plus 5 exists on top and bottom, so it cancels. So what is left? Well, what is left is 3 and 3q plus 1 on the top, and 2, right? And on the bottom is just q. Okay? Is just q. All right. So here we go. We can multiply the top. 3 times 2 is 6. 6 times 3 is 18q. 6 times 1 is 6 over q. And that is it. That is the original function simplified. All right, and it is quite a bit simpler than it was before.